In this video, we drift to the very end of time. We watch our sun grow old, see the last star in the universe quietly fade, wander the long age of black holes, and rest in the deep calm that follows. It is all unimaginably far away. Settle in and let go. Tonight we begin the longest story ever told. It starts here, beneath a familiar evening sky, and it travels forward through time, farther than any tale has ever gone out, toward the calm and distant ending of everything. There is no hurry in this story. Nothing in it asks anything of us. We are only travelers tonight, wrapped in the dark, watching the future unfold the way clouds unfold, slowly and without any sound at all. Before we go anywhere, it helps to know where we are. The universe, as far as anyone can measure, is about 13.8 billion years old. That sounds ancient. In truth, it is still astonishingly, wonderfully young. 13.8 billion years is only the opening line. Everything that has ever happened, every star, every ocean, every quiet morning fits inside that first sentence, and the story stretches on for trillions upon trillions of years. Imagine the whole life of the universe pressed into a single year. The first galaxies flicker on in late winter. Our sun is born in early autumn, and all of human history arrives in the final seconds before midnight. But that calendar only maps the past. Tonight we are traveling the other way, past the final stroke of midnight, and into a future so long that this entire year would shrink to less than a single breath. If the universe were a person, it would be a child still, a toddler blinking at its own bright rooms. Almost all of its life lies ahead of it, unlived, unhurried, waiting in the deep quiet of time. This is the season of stars. Look up on any clear night and the sky is crowded with them, thousands visible to the eye alone, hundreds of billions gathered in our galaxy, each one burning steadily in the dark. Everywhere we can see, new suns are still being kindled. Inside vast clouds of gas and dust, gravity gathers matter into dense glowing knots, and one by one they ignite, small lights switching on across the enormous night. Yet stars are not forever, and neither is the age of stars. Like a long summer, this bright era will one day fade into an autumn, then a winter so far away that numbers themselves grow sleepy trying to reach it. And here is the first gentle truth of the journey. Nothing we will witness tonight is near. The endings we visit lie billions, then trillions of years away, distances in time so vast they cannot touch this moment. Tonight the stars still shine. The sun will rise tomorrow just as it rose this morning, warm and ordinary and faithful. Whatever far futures we wander through, this present moment remains untouched, held safe on the near shore of time. You can let the numbers wash over you like water. 1 billion years, 1 trillion years, a 1 followed by 100 zeros, they are not warnings, they are only measurements of how much room the universe has to rest. Think of how a coastline forgets each individual wave. The universe holds time the same way, in long silent layers, and tonight we are simply reading those layers forward, one calm page after another, into the deep future. So let me sketch the road before us in one soft breath. First, we will watch our own sun grow old, swelling and settling like a fire banked for the night, leaving behind at last a small warm ember. Then we will see whole galaxies glide slowly together, and skies grow calm and empty as space itself keeps stretching. We will meet the small red stars that outlive everything, glowing for trillions of quiet years. We will stand beside the very last star as it dims, and then wander an age of cinders and sleeping worlds. We will visit the long reign of black holes and hear how even they in time let go. And at the last of all, we will float in a darkness, so complete and so serene that it resembles the moments before a dream, and there we will discover something surprising. The end of everything can feel like peace. Some of what lies ahead is known with real confidence. Read from the light of distant stars and the sure mathematics of gravity. Some of it is honest guesswork, and whenever we reach those places I will say so plainly. Because no one has ever seen the future. Physicists build it from patterns, from the way stars burn and space expands, and their map is careful and beautiful. Still, at its far edges, the map fades into open wonder. Perhaps that is the loveliest part of tonight. We are looking farther ahead than any creature has ever looked, and the view is not frightening. It is spacious, it is quiet, it has all the time there is. So settle a little deeper into the dark. Let the breath grow long and easy. The story will carry itself from here, moving gently forward through the ages, and there is nothing to hold and nothing to do. Every long journey begins with a single familiar landmark, and ours is already overhead. Of all the stars in all the sky, one matters most to us, the near one, the warm one, the one that made us possible. It has burned for 4.5 billion years already, steady as a heartbeat, and it will burn for billions more. Its story is where our journey truly begins, with the long golden life of our sun. And so the longest story begins where we are, with the small yellow star that warms this page of it. The sun has been shining for 4.5 billion years, calm and steady, a lantern in the dark. It seems eternal, the way mountains seem eternal, yet the sun is a slow fire with a beginning and an end. Deep in its core, hydrogen is quietly becoming helium, and every second the star grows a little brighter. This brightening is gentle beyond imagining. Over 100 million years, the change is barely a whisper, a candle turned up by a breath. Nothing rushes here. The sun keeps its promises on timescales. No living thing can feel. Long before anything dramatic happens, that slow warming will change the worlds nearby. In perhaps 1 billion years, Earth's oceans will begin to thin into the sky, water rising as vapor, carried off atom by atom into space. By then, unimaginable stretches of time will have passed. Whatever becomes of Earth's seas happens on the far side of a gulf of years, wider than all of human history multiplied beyond counting, a future too distant to fear. 5 billion years from now, the deep change arrives. The core of the sun runs low on hydrogen, and the balance it has kept for so long begins, with great calm, to shift toward something new and vast. The core contracts and warms while the outer layers do the opposite. They loosen, they billow, they reach outward like a breath released after an age of holding. Our star begins to swell into a red giant. A red giant is a star grown enormous and cool at its surface. Its light turned the color of embers in autumn. The sun will grow more than 100 times wider than it is today, a soft crimson lantern. Its edge creeps onward across the stillness of the inner solar system. Mercury, the small gray world of craters, is taken in first, folded into the sun's thin outer glow like a pebble received by a rising tide. Venus follows, the bright morning star of 10,000 human poems, gathered back into the body that made it. There is no violence in this, only an unhurried embrace, matter returning to matter after billions of years apart. And Earth. No one knows for certain what becomes of Earth. The swollen sun may reach just far enough to take it in, or the planet may slip free on its widening orbit and remain scorched but whole. Either way, by then, Earth has been quiet for ages. Its oceans left long ago, its continents keep no footprints, and whatever life once flowered here has had billions of years to become something else, somewhere else perhaps. Farther out, the cold worlds warm for a while, ice softens on distant moons, and for a brief season of a few 100 million years, the outer solar system knows a mild red afternoon it never had before. The giant sun burns helium now, fusing it into carbon and oxygen, the same atoms that will one day sit at the heart of its remnant. But this second fire is brief, as stars measure things, and unsteady. In its final age, the sun begins to let go. With each slow pulse, it releases some of itself into space, shells of glowing gas leaving home, expanding outward like rings, spreading on a pond of light. Astronomers call this a planetary nebula, though it has nothing to do with planets, only an old name for a beautiful thing. Lit from within, the shed layers glow in greens and golds, a flower opening in the dark. For 10,000 years or so, our star wears this luminous farewell, visible across the galaxy to any eyes that happen to be watching. Then the bright shells thin and disperse, and become part of the space between stars. What remains at the center is small and astonishing. A white dwarf, the exposed heart of the sun, all its remaining matter settled into a sphere about the size of Earth, dense beyond anything our hands have ever held. A teaspoon of white dwarf matter would outweigh a car, yet this heavy little remnant makes no new light of its own. It simply holds the warmth of everything it used to be and lets it out across the ages. Notice what does not happen. There is no supernova, no shattering explosion. Our sun is far too small for that ending. Only stars many times its mass go out in fire. Ours goes out the way candles do, in quiet. And this quiet is a kind of endurance. The white dwarf will cool for spans of time far longer than everything that came before, an ember still holding warmth when the galaxy itself has grown old. If you could stand on some far future world and find it, you would see only a faint white point, modest and steady, giving away nothing of the mornings it once made, the summers, the long blue afternoons, This ember will outlast almost everything. It will outlast the mountains, the constellations, the very shape of the night sky. In the deep future we are traveling toward, remnants like this one become the oldest things there are. But long before our sun fades to that pale ember, the sky itself will be rearranged. Even now, across 2.5 million light-years of silent darkness, another great city of stars is on its way toward ours. And while our sun is writing its long, quiet ending, something even larger is unfolding above it, a story told not by one star but by hundreds of billions of them moving together across the darkness between galaxies. Far beyond the edge of the Milky Way, our home galaxy, there is a neighbor called Andromeda, a great spiral of stars so distant that its light takes 2.5 million years to reach us. On clear autumn nights, it appears as a faint smudge of glow, the most distant thing human eyes can see without help, an entire island of stars resting quietly in the vast dark ocean of space. And Andromeda is coming toward us. Right now, as these words are spoken, it is closing the distance at about 250,000 miles every hour, gliding through space on a path shaped by gravity alone. That sounds impossibly fast, and it is, yet the gulf between our galaxies is so enormous that even at this tremendous speed, the crossing will take about 4.5 billion years, roughly the age of the Earth. So there is no hurry in this meeting. It is the slowest embrace imaginable, two spirals of starlight leaning toward one another across millions of light years, drawn together by nothing more than their own steady weight. Picture the night sky of a world far in the future. Andromeda no longer looks like a smudge. It has grown into a broad river of pale light, arching over the horizon, a second Milky Way slowly rising. Night after night, over millions of human lifetimes, that river of light widens and brightens, until at last the two galaxies begin to touch, their outer arms of stars and gas brushing against each other like slow water. And here is the kindest secret of the whole encounter. When these galaxies pass through one another, the stars themselves almost never collide. Not once, in all likelihood, across hundreds of billions of stars, does one sun strike another. Space is simply that empty. If our sun were a grain of sand resting in the middle of a city, its nearest neighboring star would be another grain of sand in a city far down the coast. Between them lies almost nothing at all, only faint wisps of gas and the long silence of the void. So when two galaxies merge, their stars glide past one another like fireflies crossing an enormous darkened field. The gas, though, is a different story, a lovelier one. Great clouds of hydrogen drifting between the stars do collide, and where they press together they grow dense and heavy and begin to fold in on themselves. Out of that folding comes light. Wherever the clouds compress, new stars ignite by the thousands, and the merging galaxies bloom with fresh blue fire, a burst of star birth unlike anything either spiral has known for ages. For a while, the combined galaxy becomes a nursery on the grandest scale, glowing ribbons of newborn suns threading through the dark, each one beginning its own long life in the middle of this ancient, unhurried collision. Any watchers on any worlds would see their night skies rearranged over countless ages, familiar constellations dissolving, new rivers of starlight pouring across the heavens, the whole ceiling of the world remade in extreme slow motion. The two galaxies do not merge in a single pass. They swing through one another, pull apart, and fall back again, a swaying dance repeated over billions of years. Each returns softer and closer than the last. By degrees, the graceful spiral arms loosen and blur, their delicate pinwheel shape softening into a vast rounded cloud of stars. What remains is one great elliptical galaxy, a golden swarm that some astronomers fondly call Milkomeda. Our own sun will very likely still be shining when this happens, an old star nearing its red giant years, carried into new territory as the merger sweeps whole families of stars into wide looping orbits. Deep at the heart of each galaxy waits something heavier still. Both the Milky Way and Andromeda carry a supermassive black hole at their centers, each holding the mass of millions of suns folded into darkness. As the galaxies settle together, these two giants sink down toward the shared center, circling each other in an orbit that gradually tightens over millions of years, closer and closer, like two whirlpools joining into one. And when at last they touch and merge, space-time itself trembles. Ripples called gravitational waves spread outward from the union, gentle stretchings of space that travel at the speed of light across the entire sleeping universe. By the time those ripples pass through distant worlds, they are unimaginably faint, a change smaller than the width of an atom. The universe absorbs even its greatest events as the quietest of whispers and carries gently on. Then the great new galaxy settles. The flare of star birth fades, the orbits smooth themselves out, and hundreds of billions of suns find their places in a calm golden haze that will glow for ages to come. And beyond that golden haze, far past the edges of our merged home, something subtler is already underway. The other galaxies of the deep sky are beginning ever so gradually to slip away into greater distances. And when the merging is complete, when our two great spirals have settled into a single golden sea of stars, the new galaxy rests whole and calm, while far beyond its shores something quieter still is beginning. It is the space between things that is changing. Astronomers call the cause dark energy, a gentle pressure woven into emptiness itself, and it does not push galaxies apart so much as stretch the distances between them. Imagine dough rising in a warm kitchen, raisins scattered through it. No raisin moves through the dough, yet every raisin finds every other raisin farther away. Space itself is the dough, quietly rising, and galaxies are the raisins. The farther away a galaxy lies, the more stretching space stands between us and it, and so the faster it seems to recede. The most distant galaxies are already receding faster than light itself can swim against the current. This breaks no law of nature. Nothing travels through space faster than light. But space itself is free to grow at any pace it pleases, and it carries its galaxies with it, the way a river carries sleeping boats. Because of this, there is a horizon in the sky, a distance beyond which light can never finish its journey to us. It is not a wall, it is simply the place where the river outruns the swimmer. For now, the horizon is generous. Tonight, telescopes can gather light from hundreds of billions of galaxies, ancient photographs arriving from every direction, some of them older than the Earth, older than the sun that warms it. But dark energy is not resting. With every passing age, the expansion quickens, and one by one the farthest galaxies cross that invisible line, their light growing redder and fainter until no instrument could ever hope to catch it. A galaxy does not vanish all at once. Its final light keeps arriving for ages, stretched thinner and thinner, its colors sliding down past red, past infrared, into radio whispers, then into wavelengths longer than any telescope could ever measure. There is no flash when a galaxy slips away, no sound, no shadow. It fades the way a ship dwindles over the curve of the ocean at dusk, still sailing, still shining somewhere, only no longer shining for us. Give the universe 100 billion years, perhaps a little more, and this quiet departure becomes nearly complete. Almost everything we can photograph tonight will have passed beyond the horizon, out of reach, out of sight, out of story. Almost everything, but not quite. Gravity holds our neighborhood together. The merged galaxy of Milky Way and Andromeda, along with a small family of companion galaxies, remains bound, a single island of starlight that dark energy cannot pull apart. Astronomers call this family the local group, and it is local in the truest sense, held close by its own gravity, while the great ocean of space widens around it. Within its bounds, nothing changes. The stars still turn. So the sky performs its slowest disappearing act. Century by century, aeon by aeon, the faint smudges of distant galaxies dim and darken like harbor lights winking out one at a time along an endless evening coastline. No one standing beneath that future sky would notice the change within a single lifetime. The emptying is far too slow for that. It is a tide that takes billions of years to turn, and it never hurries. Even the oldest light of all, the faint warm glow left over from the beginning, stretches away with everything else, thinning toward perfect silence until the story of the early universe is written in ink too pale to read. And here the mind wanders to a tender thought. Imagine astronomers born on some far future world inside our lone surviving galaxy, lifting their telescopes toward a night that holds their own stars, and beyond them, nothing at all. They would map their galaxy carefully, count its suns, chart its slow rotation, and conclude with perfect honesty and perfect care that their island of stars is the entire universe, floating alone in an endless dark. All the evidence of expansion, all the ancient light that taught us how the cosmos began, will have left their sky completely. They will not be wrong through any fault of their own. The clues simply will have sailed away. Some cosmologists point out how fortunate we are to be awake in this bright morning of the universe, when the whole story is still visible, when the deep past still shines down on every clear and quiet night. And if the far future sounds lonely, consider how it might actually feel. Not lonely perhaps, but still, as a house settles after midnight, everyone safe inside, the wide world outside resting under its own dark blanket. The island galaxy keeps all its warmth within its shores. 1 trillion stars remain with their planets and moons, their auroras and slow seasons, everything a sky could ever need, gathered close beneath one gentle roof of night. Within that quiet realm, time keeps its own slow business. Bright blue stars burn out first, then yellow suns like ours fade to embers, and gradually the galaxy's light shifts toward deeper and redder and more enduring flames. For the smallest stars, the dim red ones, are still young. They sip their fuel so sparingly that they will glow for trillions of years, and the long, calm age that belongs to them is quietly waiting to begin. And as the great lights dim one by one, something small and steady remains. Across the quieted sky, the humblest stars of all keep shining, unhurried and calm, as if the universe saved its gentlest lamps for last. These are the red dwarfs, stars so modest that many hold barely 1/10 the mass of our sun. They glow a deep ember red, so faint that no unaided eye has ever seen one from Earth. In stars, smallness is a kind of wisdom. A red dwarf sips its hydrogen the way a candle guards its wax, spending only a whisper of fuel each moment, and so its life stretches on almost beyond imagining. Larger suns burn only their cores and leave the rest untouched, but a red dwarf stirs itself completely. Slow currents carry fresh hydrogen down into the fire, mixing the whole star like tea swirled in a warm cup. Because of that quiet stirring, almost nothing is wasted. Nearly every atom of hydrogen the star was born with will someday find its way to the center and become warmth, released in the smallest, most careful of doses. And so these little stars endure for trillions of years, not billions like our sun, but trillions, a span so long that the entire history of the universe so far is only its first brief morning. Imagine a lifetime measured in ages of ages. A red dwarf born among the very first galaxies, more than 13 billion years ago, has scarcely begun. It is still an infant, and it will outlive everything we have ever known. Consider our nearest neighbor, Proxima Centauri. It is a red dwarf, small and dim and faithful, hanging just beside the bright pair of Alpha Centauri, though closest of all the stars it is too faint to see. Long after our sun has swelled and faded into a cooling white cinder, Proxima will still be shining. When the sun is a cold memory drifting among the dark, that small red lamp will burn on, steady as ever. Some estimates give Proxima 4 trillion years of quiet burning, perhaps more. If that whole life were a single year, then everything that has ever happened, all of cosmic history so far, would fit inside its first day or so. Now let the ages roll forward. In their own time the bright suns finish their stories. The blues and golds and whites retire into stillness, and the sky that remains belongs more and more to the small red ones. This is the Age of Red Dwarfs, an era longer than any before it. Across every galaxy that still holds together, the only steady light comes from these ancient embers, glowing in their deep and dusky crimson. If eyes existed to look up in that time, they would find a dimmer, warmer heaven. No blazing white beacons, no blue giants, just countless small red points, calm as the coals of a fire settling for the night. In truth, they were always the great majority. Even today, most of the stars in our galaxy are red dwarfs, hidden from us by their faintness. The universe was always quietly, mostly made of gentle light. And around those small suns, worlds still turn. Planets huddle close to catch the warmth, and their skies are washed in amber and rose, a permanent late afternoon that lasts longer than any afternoon has a right to. Many of those worlds keep one face always toward their star, the way the moon keeps one face toward Earth. On such a planet there is a land of endless sunset, where the light never moves and never fades. Those amber evenings can last for spans 1,000 times longer than the universe's current age. Whatever stories such worlds may hold, they are given time beyond counting to unfold, warmed by a sun that simply refuses to hurry. No one knows whether anything will live beneath those quiet red skies, but if life needs time above all else, then the Age of Red Dwarfs offers more of it than any era before or after, an almost endless invitation. Even the end of a red dwarf is peaceful. There is no explosion waiting for it, no sudden farewell. When its fuel finally runs low, trillions of years from now, it will simply warm, brighten a little, and settle. Physicists suspect the oldest red dwarfs will glow briefly bluer near the end, then fade into small white dwarfs, dense and still. No red dwarf has ever died yet. The universe is far too young to have seen one. There is something restful in that thought. Every red dwarf that has ever been born is still shining tonight, every single one, an unbroken company of small lights that has never yet lost a member to the dark. So when sleep comes for you tonight, you might picture them, the little red suns, keeping their long watch. They ask for nothing, and they hurry for no one, and they will be here almost until the end. Yet even in this long red evening, the universe is not quite finished with beginnings. Here and there in the last unspent pockets of gas and dust, something is still gathering itself slowly in the peaceful dark. Because before this story dims any further, there are a few more candles left to light. Somewhere ahead, in the deep quiet of the far future, the final newborn suns are waiting for their turn to open their eyes. And while the small red suns keep their quiet vigil, something else is changing across the universe, something slower still. The raw material of starlight, the cold gas that gathers in the dark, is gradually running low. Every star that has ever shone was born from a cloud, a vast reach of hydrogen colder than any winter, folding in on itself until it warmed into light. For all this time, the clouds have been plentiful. Galaxies have been great recyclers. When heavy stars ended, they breathed their substance back into space, and new clouds formed from the old breath, and new stars kindled inside them, birth and return, turning like a slow wheel. But the wheel is not perfect. With every turning, a little of the gas is kept forever, locked inside white dwarfs and other quiet remnants that will never give it back. Each generation of stars leaves less for the next. So the galaxies dim, not suddenly, but the way a fire settles through a long evening. Each hour a little lower, each new flame a little rarer, until the hearth glows more with memory than with burning. There is no hurry in this dimming. It unfolds over spans of time that make the present age of the universe seem like a single indrawn breath, a moment at the very beginning of an immense and tranquil night. Somewhere between 1 trillion and 100 trillion years from now, the last of the great stellar nurseries will close. The final clouds will gather themselves, fold inward, and kindle their final stars, and then the making will be done. No one can say exactly when. The gas thins the way a snowfall thins, a few flakes still falling long after the sky has mostly cleared. The last true cloud may linger far longer than anyone expects. Picture a galaxy in that far era. Its spiral arms, once bright with blue newborn suns, have faded to a deep and restful red. The red dwarfs remain, countless and steady, like watchfires banked for the night. The color of the whole sky changes over these ages. Where galaxies once shone white and blue, they now glow amber, then crimson, the light of small, old suns pooling together like lamplight through a curtained window. And yet the story of starbirth does not end all at once. Even after the nurseries close, the universe keeps a few small surprises folded in its pockets, quiet ways of striking a light long after the matches are gone. Scattered through every galaxy are the brown dwarfs, the almost stars. Each one gathered dust and gas just as a sun does, but never grew heavy enough for its heart to catch fire. They warm the dark only faintly. They are gentle failures, if failure is even the word, heavier than any planet, lighter than the smallest sun. They glow a faint ember red from the leftover warmth of their making, cooling quietly across the long ages. For most of their existence, they simply wander, unlit lanterns carried among the true stars. But space, though vast, is not perfectly empty, and given enough time, oceans of it, even the unlikeliest of meetings, will eventually come to pass. Once in a great while, across all those years, two brown dwarfs find each other in the dark. They circle, draw close, and merge, and their combined weight is at last enough to press their center into burning. And so, ages after the nurseries have closed, a genuine star ignites. Two failed suns become one true one, a small red flame opening its eyes in a universe that had almost forgotten how new light feels. It is a brief candle, as such things go. Brief in that era still means trillions of years of steady shining. Even the accidents of the far future are more enduring than everything our young universe has known. Imagine that single new star from far away, one warm point waking in a galaxy of embers. Nearby, nothing celebrates and nothing stirs. It simply begins and shines, and the darkness around it becomes a little kinder. These chance ignitions grow rarer and rarer as the ages pass. The wanderers thin out, the meetings become fewer, and each new candle is separated from the last by gulfs of time too wide for any imagining. This is the universe's long evening. Not an ending, but a settling, the way a house settles after the day's work is done. Lamps going out one by one in quiet rooms where everyone is already sleeping. There is nothing to fear in an evening. Evenings are when the light turns golden and the world grows soft at its edges. The cosmos is simply doing on the grandest scale what every home does at the close of day. If you could stand somewhere in that far evening and look up, you would still see stars, fewer, redder, farther between, but stars all the same, keeping their appointments with the dark, just as they always have. And every star still burning is spending its fuel with red dwarf thrift, hoarding each moment of warmth, so that even now, with the nurseries dark, the long shining of the universe is still far from over. But somewhere ahead, among the embers and the late-born candles, there waits one small flame that will outlast all the others, one final point of warmth in the great dark, and it is toward that light we are now traveling. And those final newborn stars kindled from the universe's last spare breath of gas live out their long red lives in a sky that keeps growing quieter around them, one small warm light after another settling toward rest. Time moves on in spans too wide for any calendar. 100 trillion years arrive the way deep sleep arrives, without a single boundary you could point to, only a gradual and complete surrender of the light. By then, the great bright galaxies of old are only memories written in cooling embers. The red dwarfs, those small and frugal stars, are the last lamps still burning, spending their fuel a whisper at a time. One by one, across ages we have no names for. Even they finish, each little star quietly closes its long account with gravity, dims and lets go, until the sky holds fewer lights than a country road at midnight. And then, somewhere in all that darkness there is only one, a single red dwarf, the last true star in the entire universe, still casting its small, steady glow into a night that has grown infinitely wide. It is not grand. It is smaller than our sun ever was, dimmer than a candle seen across a valley, and yet it holds a title no other object will ever hold again. It is the final light. For trillions of years, this little star has been careful with itself. Its whole body stirs like slow soup, carrying fresh hydrogen down into the core, so that almost nothing is wasted and almost everything is turned to warmth. But even the most enduring fire reaches the bottom of its fuel. Deep inside, the last of the hydrogen is thinning now, and the star begins the strangest and loveliest passage of its long, unhurried life. Instead of swelling into a red giant as our sun once did, a dying red dwarf does something kinder. Physicists expect it to grow warmer and brighter near the end, its ember glow turning slowly toward blue. No one has ever seen this happen, because the universe is far too young for any red dwarf to have died. This is a sunrise predicted, not remembered, a color the cosmos has not yet worn. So picture it as the models do. The last star in its final age, brightening like a coal breathed upon, shifting from deep red through orange toward a pale and wintry blue-white, one long quiet crescendo of light. There is no explosion waiting at the top of that crescendo. The star is far too small for a supernova, too calm for violence of any kind. It simply finishes the way a long exhale finishes, completely. The fire in the core goes still. The star lets its outer warmth loosen and settle, and what remains draws inward, folding down into a small dense remnant, a white dwarf no larger than a rocky world. Stay with this moment a while, because nothing like it will ever come again. Somewhere in the dark, the very last starlight ever to shine is thinning, dimming, easing itself down toward a final gentle dusk. There is no eye left to watch it happen. No telescope, no upturned face, no astronomer keeping vigil. The light goes out as lights so often do, quietly in an empty room with no one to see. And yet the moment is not lonely, not really. The last photons leave the star's surface and set out across the dark, tiny travelers, carrying the memory of starlight outward on a journey that never has to end. Long after the star has gone dim, that final light is still moving, still real, threading its way between the cold remnants of galaxies. In a sense, the last starlight never dies. It only travels farther from home. But at the surface where it began, the glow keeps easing away. Red fades to a deep and quiet brown, brown loosens into darkness, and the sky closes its last bright eye without a sound, without regret. After this, no new light of that kind will ever shine again. There is no hidden nursery waiting, no spare cloud of gas being saved for later. The age of stars, the whole luminous story is complete. And how gently that story chooses to end, not with a blast or a wound in the sky, but with one small faithful star finishing its work, folding its warmth away like a blanket at the end of winter. Think of every star that ever burned, from the first blue giants to this last modest ember, trillions upon trillions of suns, each one a held note in a song that lasted 100 trillion years. The song has ended now, but songs do not end into nothing. They end into silence, and silence is its own kind of presence, wide and calm, the resting place all that music was moving toward. And the darkness that follows is not empty. Scattered through it, beyond counting, are the remnants the stars left behind, white dwarfs still carrying their old heat inward, like stones that remember the sun after nightfall. The universe is not over. It has only banked its fires for the night. Everywhere in the dark, warm coals glow on in secret, and their slow cooling will be the next long, peaceful part of the story. And when that final flame has gone out, the universe does not end. It simply changes its way of being. What follows is not emptiness, but a long, warm afterglow, an age of embers stretching farther than imagination can reach. Cosmologists call this the degenerate era, a strange name for a peaceful time. It only means that matter has settled into its calmest forms, dense, quiet remnants of stars, resting in configurations that ask nothing more of the cosmos. Everywhere in the darkness, white dwarfs remain. Each one is the cooling heart of a star that lived and finished its work, a sphere the size of a small world holding the compressed memory of something sun-like. They make no new light of their own. They only release the warmth they already carry. The way a stone by the fireside keeps giving back its heat long after the flames themselves have quietly gone to sleep. And this letting go takes almost forever. A white dwarf needs far longer than the present age of the universe just to fade from white heat to a deep and dusky red, dimming by the most delicate degrees. Somewhere at the far end of that cooling lies a thing called a black dwarf, a stellar remnant gone completely cold and dark. And here is a gentle secret: not one of them exists anywhere yet. The universe, nearly 14 billion years old, is still far too young to have finished cooling even a single one. Every white dwarf ever made is still warm, still glowing faintly like coals that refuse to be done. As these small suns cool, something lovely happens deep inside them. Their carbon and oxygen atoms, squeezed to unimaginable density, begin to settle into a lattice, arranging themselves in ordered rows the way water becomes ice. The interior of a white dwarf slowly crystallizes from the center outward until most of the star is one vast solid structure, a crystal heart the size of the Earth grown in silence over billions of years. Astronomers have already seen the first signs of this in nearby white dwarfs today. A pause in their cooling as the crystal forms and releases heat. The night sky, it turns out, is quietly growing jewels. Imagine holding that thought as you rest. Above the roof, beyond all weather, ancient stars are turning themselves into diamonds of a kind, one atom at a time, with no hurry at all and nowhere to be. White dwarfs are not the only dreamers here. Scattered through the dark are neutron stars, remnants of much heavier suns, each one a city-sized sphere so dense that a spoonful would outweigh an entire mountain. In their youth, they spun with astonishing speed, some of them hundreds of times every second, sweeping beams of radio light across the galaxy like lighthouses. Now in the Ember Age, even they are slowing down. Over trillions upon trillions of years, their rotation gently unwinds, those bright beams fading, the pulses spacing farther and farther apart, until each neutron star turns as calmly as a sleeper rolling over in the night. If eyes like ours existed then, the sky would look almost empty, but eyes made for infrared, for the language of warmth itself, would see the heavens still speckled with soft points of heat, countless and calm. Where stars once blazed white and blue and gold, there is now a dim glow, the color of a kettle just switched off, the color of a hand warmed by another hand. The universe has become tender heat. And our galaxy itself is still here. That is the quiet wonder of this age. Nothing has scattered it. Our merged galaxy of embers still turns, a vast, slow wheel of dark remnants circling a common center. Gravity remembers everything. It holds each cooling star to its ancient orbit, The same paths traced when those stars were young and burning. The music has ended, and yet the whole orchestra keeps swaying to its memory. A galaxy of embers takes hundreds of millions of years to turn just once, and it has time for countless turnings, round and round in the dark, unhurried, unwitnessed, held together by nothing but gentle mutual attraction. All of this lies 100 trillion years away, a span so much larger than our little moment that the numbers stop meaning anything. It is not a threat approaching, it is a lullaby written in deep time. Perhaps that is the kindest way to picture the Ember Age. A house after midnight, every lamp off, the hearth still faintly warm, everything in its place, nothing needing to be done, the whole home breathing evenly. The cosmos in this era is not dead so much as deeply asleep. Its stars have become keepsakes of themselves, crystal hearts and slowing spheres, each one carrying its whole story inward, holding it safe and warm. And the stars are not alone out there around many of these embers, and adrift between them move darker companions, worlds without suns, planets that have kept their quiet journeys long after the light went away. Some circle their sleeping stars the way the earth still circles the sun. Others travel alone through the spaces between, free and unbound. Their stories are strange and beautiful, and they are where we will wander next. And as the embers dim, the worlds that circled them remain, long after the last starlight has cooled into darkness. Planets endure, quiet and whole, still tracing their ancient orbits around the faded hearts of their suns. A planet does not need light to keep going. It needs only gravity, and gravity never tires. So the frozen Earths of the far future continue their slow circles, faithful to stars that no longer shine at all. Picture one of them, a world about the size of our own, sealed in ice, turning through perfect darkness around a black dwarf, a stellar remnant so cold it gives off almost no warmth and no light whatsoever. No sunrise has touched this world in trillions of years. Its skies hold no dawn, no noon, no dusk. Yet it is not empty of story. Its surface remembers in layers of frost everything that ever fell upon it. And some of these sleeping worlds hold a secret beneath the ice. Deep under their frozen shells, a few may still keep oceans, liquid water in the dark, warmed not by any star but from within. Every rocky planet carries a faint inner fire. Radioactive elements in its core release a gentle heat as they decay, the way a banked hearth keeps a house warm long after the flames have gone out. Moons help too. When a moon circles close, its gravity kneads the world beneath it, flexing the rock like dough, and that endless squeezing makes warmth. Tides, in the far future, become quiet furnaces that keep hidden seas from freezing. So imagine it, an ocean that has never seen a sky, black water under miles of ice, resting in silence for spans of time that make the whole age of stars look like a single held breath. Does anything stir in those waters? No one knows. Perhaps they are only chemistry, mineral and salt and cold currents. Or perhaps in a few of them, something simple drifts and feeds and divides, unaware of endings. It is only a maybe, and science holds it lightly, but it is a lovely maybe. Life, if it lingers anywhere in that late universe, lingers in warm, hidden water, wrapped in ice, wrapped in night. Not every world keeps its place beside a star. Even now in our young universe, countless planets travel alone. They are called rogue worlds, wanderers thrown free of their birth systems, sailing the space between the stars. In the deep future, there will be many more of them, dark planets gliding between dead galaxies, crossing distances too wide for imagining, each one silent, each one carrying its own small cargo of rock and ice and memory. A rogue world has no year, because it has no sun to circle. It has no seasons, no calendar, no noon. It simply travels on and on, a seed adrift in an ocean with no far shore. And yet even these wanderers may not be barren. A large rogue planet with a thick blanket of hydrogen air, or a deep shell of ice, can hold its inner warmth for astonishing stretches of time. Some physicists suspect that such worlds could cradle liquid water with no star at all, tiny warm rooms roaming the dark, their heat trickling up from radioactive stone the way warmth rises through the floor of an old farmhouse. Worlds come loose from their suns through gravity itself, working over spans of time so long that even the steadiest, most faithful orbit becomes, in the very end, a quiet matter of chance encounters between passing stars. Every so often, over trillions upon trillions of years, one dead star wanders near another. They almost never touch. Space is far too empty for collisions, but their gravity reaches out, and each one tugs at the other's family. One near miss changes little. A planet's path stretches slightly, a comet leans a new way, but near misses keep coming, one after another, and small nudges, given enough time, add up to farewells. This is how planetary systems dissolve, not in any crash or fire, but through a kind of loosening, the way a knot worked by countless small motions eventually slips free without anyone ever pulling hard at all. One by one, over ages beyond counting, worlds part company with their suns. A frozen Earth swings a little wider each eon until one day the black dwarf it loved simply cannot hold it anymore and lets go. There is no violence in the parting. The planet keeps its speed and glides away on a long straight road, carrying its ice and its possible hidden sea out into the dark, a lantern leaving a sleeping harbor. Given enough time, this happens nearly everywhere. The old families of planets scatter gently apart, and the universe fills with solitary travelers, worlds without suns and suns without worlds, all coasting through a night that keeps them safe. If you could watch it from far away, sped up beyond all imagining, it would look like dandelion seeds leaving a stem, one lifting free, then another, each beginning its own unhurried journey across the empty meadow. And this quiet scattering is only the beginning of a larger letting go, for the same slow arithmetic that frees the planets is at work on grander things, and even the galaxies of embers have begun imperceptibly to loosen. And still the dark worlds wander, holding their frozen oceans and their sleeping stone, while the universe around them grows quieter than any quiet we have ever known. Time here is measured in silences too long to imagine. Yet even these wanderers, even the cold black dwarfs and the drifting planets, may not last forever. Deep inside every atom sits a tiny grain of matter called a proton, and its fate is one of the gentlest mysteries in physics. Protons are the steady hearts of atoms. In all our watching across every experiment ever built, not a single one has been seen to die. As far as anyone can prove, they simply endure quiet and unchanging forever. But some physicists suspect that even protons carry a clock inside them, wound almost beyond measure. If they are right, a proton lives for at least 10 to the 34th years, a 1 followed by 34 zeros. To feel that number, imagine the whole age of the universe so far, all 13.8 billion years of it, as a single second. Even then, a proton's life would stretch longer than trillions upon trillions of such seconds. No one knows if this is true. The great underground detectors filled with still water and quiet light have waited for decades and seen nothing. Perhaps protons truly are immortal. Perhaps their clock is only hidden more deeply. So the story of the deep future comes to a fork in the road, and we must walk both paths in imagination. Down one path, matter lasts forever. Down the other, it dissolves with unimaginable slowness into light. Let us follow the second path for a while, the one where protons decay, remembering always that it is a suspicion and not a certainty. It begins somewhere past 10 to the 34th years in absolute darkness. Here and there, in the heart of a black dwarf or a frozen wandering world, a single proton lets go. It becomes lighter particles and a small flicker of light, one atom quietly closing its long story. Each decay releases a whisper of warmth. Added together across a whole dead star, these whispers keep the black dwarfs faintly warm, warmer than the space around them, glowing with the heat of their own unmaking. This is not destruction as we usually picture it. Nothing shatters, nothing burns. Matter does not break apart so much as exhale, releasing its bound light bit by bit, the way a held breath is finally, peacefully let go. Imagine one of those black dwarfs, a crystal sphere of carbon and oxygen, cold and perfect. Over spans of time we can hardly fathom. It grows lighter, atom by atom, its substance turning into photons that sail away forever. It is like a sculpture of ice left in a room just above freezing, except the melting takes longer than anything our words were made for. The sphere does not notice. It has no seasons, no days, no hurry. The wandering planets share the same fate. Their iron cores, their frozen oceans, their mountains of ancient stone, all of it thins across the ages, evaporating not into steam but into light and particles lighter than atoms themselves. If this is how the universe goes, then by around 10 to the 40th years, a 1 followed by 40 zeros, nearly all ordinary matter has completed its exhale. The stars that were, the worlds that were, have become light. That light spreads outward through the empty dark, thinner and dimmer as space keeps stretching, carrying in its faint glow the memory of everything it once was. Iron and ice, mountains and moons, all traveling now as radiance. Nothing is truly lost in this. The energy remains, only changed in form, the way a song remains in the air for a moment after the singer falls silent. The universe keeps every account, even across these depths of time. And now let us walk back to the fork and take the other path, the one where protons never decay at all. Down that road, the black dwarfs and the wandering worlds simply remain unchanged for spans beyond every number. In that version of the story, this era stretches so far that even the ages we have already imagined become a brief opening breath. Cold spheres of crystal sail on through darkness, outlasting every word our languages hold for time. We do not know which path the universe walks. That honesty is part of the wonder. Either matter is a long, slow exhale, or it is a promise kept forever. Both endings are quiet, both are entirely without pain. And remember how far away all of this is. Between tonight and that unraveling lie more years than there are grains of sand on every shore of every world. You are resting at the very beginning of everything. If the dissolving path is the true one, then when it is finished, almost nothing solid remains anywhere. No stone, no ice, no crystal spheres, only faint light, thin seas of particles, and a few vast and silent survivors. For there are objects in the universe that no proton clock can touch, deep wells of gravity that swallowed stars long ago and hold their darkness close. While matter exhales, they simply wait, unmoved by all this quiet change. They are the last great landmarks of the cosmos, heavier than anything else that remains, and in the ages ahead they will inherit everything. The universe is about to become their kingdom, and their reign will be the longest of all. And as that long unraveling completes itself, as the last loose matter thins into the dark, something remains. Not everything has come undone. Scattered through the emptiness, a few immense presences endure, holding their shape against the ages. They are black holes, the deepest wells that gravity ever made. Everything else has faded or dissolved, but these remain silent and complete. In the whole dark universe, they are now the largest things that still exist. The galaxies that once held them are gone. Over spans of time almost beyond naming, their stars wandered too close to one another, again and again, and each near meeting nudged some outward, a little farther every time. There were no collisions, no violence in this space. Between stars is so vast that they almost never touch. Instead, they simply traded momentum in passing, the way strangers exchange a glance, and some were freed forever. One by one, the sleeping remnants of stars were flung into the space between galaxies, set loose to travel alone. Others fell the opposite way, spiraling inward across the ages toward the great dark heart of their galaxy. That heart received them without hunger and without haste. A supermassive black hole, a region where gravity folds so deeply that nothing which enters can return, simply grew a little quieter, a little heavier with each arrival. So the galaxies emptied themselves over unimaginable time, some of their remnants scattered outward into the endless dark, some gathered inward into a single deep stillness. What had been a city of stars became one solitary keeper. Now imagine the universe in this age. It is dark beyond all darkness, colder than any winter, and stretched thin by expansion that has never stopped. And spaced across it, far apart, the black holes keep their places. Some are small, the ghosts of single stars that collapsed in the deep past. Others are giants beyond easy imagining, heavier than 100 billion suns, grown fat in the bright ages on gas and starlight and time. 100 billion suns, drawn into one long silence. Once, such a giant would have blazed at the center of a quasar, outshining its whole galaxy. Now it is orbited by nothing at all, attended by no one. There are no glowing disks anymore, no jets of light, no infalling clouds to warm the dark. The feasting ended long ago. Each black hole rests in perfect quiet, a closed door in an empty and endless hallway. If you could stand near one, you would not see a thing so much as an absence, a round and perfect darkness, its edge bending the last stray light of the universe into slow curved paths. And near that edge, something stranger still is true. Time itself runs differently there. Gravity is not only a pull on matter, it is a bending of time, and close to a black hole the bending grows deep. A clock resting near the horizon would tick more slowly than one far away, not because its gears struggle, but because time there flows at a different pace, thick and unhurried like honey in the cold. Hover close enough, and ages could pass in the wider universe while only moments passed for you. Around each black hole lies a region where the future arrives late, where eternity itself seems to lean in and rest. It is fitting, somehow, that the last kingdoms of the universe are places where time itself loses its hurry, as if the cosmos, growing old, has learned at last to linger, to hold each remaining moment a little longer. And linger they will. The reign of the black holes lasts longer than everything that came before it, longer by so much that comparison begins to fail. All the ages of stars were only the opening breath. Try to hold it. The universe today is nearly 14 billion years old. The last stars faded near the 100 trillion year mark, and black holes will endure for spans written as a 1 followed by 67 zeros and beyond. There is no picture for such a number. If every grain of sand on every beach on Earth held 1 billion years, all those grains together would not come close. The mind simply bows, and that is all right. Through all of that span, almost nothing happens. The black holes do not burn, do not build, do not change in any way an eye could catch. They only persist, holding their darkness the way mountains hold their silence. This is their kingdom, and it is a peaceful one. No storms trouble it, no wars of matter, no sudden light, only widely scattered thrones of gravity, each seated in its own vast province of empty space. And yet even these are not eternal. Even the deepest silence in the universe has hidden within it the faintest whisper, For black holes, though they seem perfectly closed, are not perfectly closed. They leak unimaginably faintly. At the edge of each horizon, physicists believe the restless quantum nature of space lets the smallest trace of warmth escape, a glow so dim that no instrument we own could ever hope to catch it. But it is there. And because it is there, even the kingdom of black holes carries a quiet ending inside it. Grain by grain, over spans beyond all spans, the great dark thrones have already begun, in secret, to let go. And even these dark kings, it turns out, are not quite eternal. In the deep quiet of their long reign, something almost imperceptible is happening at their edges, a whisper of light where nothing should be able to leave. A physicist named Stephen Hawking imagined the border of a black hole, that smooth horizon of no return, and found that quantum physics gives it a faint warmth, a glow so dim it barely deserves the name. Empty space is never truly empty. Pairs of tiny particles flicker into being everywhere and vanish again almost at once. Near a horizon, sometimes one falls inward while its partner escapes, carrying a little energy away. That stolen warmth has to come from somewhere, and it comes from the black hole itself. With every escaping flicker, the giant grows the tiniest bit lighter, the way a dune might shrink by a single grain of sand. This gentle leak is called Hawking radiation, and it means that even black holes are only borrowing their darkness. Given enough time, and the universe now has nothing but time, every one of them will give itself back. At first, the leak is unimaginably slow. A black hole born from a star radiates less warmth than a single snowflake resting in the dark, and it would take ages beyond counting to notice any change at all. In fact, for a long while, the great ones drink in more light than they lose, sipping the warmth left over from the beginning. Only when the universe grows colder than they are does the tide truly turn. Then the numbers become almost like music. A black hole the weight of a star needs about 10 to the 67th power years to fade away. A 1 followed by 67 zeros, a span with no name in any language. Set beside that, the entire history of the universe so far, nearly 14 billion years of stars and oceans and mornings, is less than a single breath, less than the first letter on the first page of a library. And the largest of all, the sleeping giants at the hearts of ancient galaxies, will last far longer still, about 10 to the 100th power years, a number called a googol, 1 followed by 100 zeros. Through all those silent ages, the leaking continues, faithful and unfailing. Each black hole becomes a dwindling candle burning backwards, giving its substance back to the dark a little at a time, asking nothing, keeping no record of its loss. And here the story turns strangely beautiful. As a black hole shrinks, it does not cool down like an ember. It grows warmer instead. The smaller it becomes, the brighter it glows, as though remembering how to shine. The faint leak becomes a steady trickle, and the trickle becomes a stream. What unfolded over unthinkable ages now quickens toward its close. the way the last sand in an hourglass always seems to hurry near the end. In its very last moments, each dying black hole blazes. All the darkness it held for so long is returned as pure light, released in one final flash that blooms against the black and then is gone forever. Some physicists suspect these flashes may be the last events that ever happen, the closing sentences of the universe's long story. After each one, the silence returns deeper than before, and nothing remains where a giant once slept. Picture them as the universe's final fireworks. Though no show was ever so unhurried, one flash, then a stillness lasting longer than everything that came before, then somewhere unimaginably far away, another, each one both a farewell and a gift. There will be no eyes to watch them, and that is somehow all right. The flashes do not need an audience. They happen the way snow falls on a mountain no one has ever climbed, complete in themselves. It should be said softly that no one has ever seen this glow. It is too faint for any instrument, but the physics behind it runs deep, and most who study it believe the giants will one day fade. Even the great heart of our galaxy, the giant at the center our stars once circled, will follow this path. Long after every sun has cooled and scattered, it too will thin into light, keeping the same appointment as all the rest. Nothing in the end is truly locked away. Everything the black holes ever gathered, the old starlight, the wandering worlds, the dust of forgotten oceans, is given back to the universe as a soft rain of particles and light. Is that not a kind of mercy, that even the deepest keepers of secrets let everything go in the end? The universe hoards nothing forever. It holds and it releases, and both are done without hurry or regret. One day, impossibly far along the corridor of time, the very last black hole will brighten, flare, and vanish. Its light will spread outward through the emptiness, a single ripple crossing a sea that has no farther shore. And when that last ripple has thinned into nothing, the universe will hold no stars, no embers, no giants, only a sparse mist of the smallest things, photons and neutrinos and quiet particles, adrift in the endless dark. But that is a story for a little later in the night. For now rest with the image of those last brave flashes, so far away in time that they cannot touch you, blooming and fading in perfect peace. And when that final flash has faded, when the last black hole has given itself back to the dark, the universe enters its longest age of all, an era with no name but darkness and no clock but forever. Nothing burns here anymore, nothing shines. The last star guttered out ages beyond counting ago, and the last black hole has melted into light that long since thinned into silence. What remains now is almost nothing at all. Almost nothing, but not quite. Space still holds a faint scattering of leftovers, the quiet survivors of everything that ever happened. Photons, neutrinos, electrons, and their mirror twins called positrons, spread through a darkness wider than imagination. The photons are particles of light, but they no longer look like light. The endless stretching of space has pulled their waves out longer and longer, until each one is a whisper too faint for any eye that ever existed. The neutrinos are ghost particles so shy that in the bright ages they could pass through whole planets untouched. Now they sail through a universe emptier than any planet ever was, and there's nothing left for them to touch. And the electrons and positrons, the small charged grains of the old world, hang impossibly far apart. Between one particle and its nearest neighbor lies a gulf greater than all the galaxies the vanished sky once held, strung one behind another. Emptiness this deep is hard to picture, so picture rest instead. Every particle floats alone, unhurried, with nowhere to be. The universe has become a bedroom after midnight, vast and dark and quiet, everything finally put away. Yet even here, in the deepest hour of the deepest night, a small tenderness remains. Once in a great while, across those unthinkable distances, an electron and a positron feel each other's faint electric pull and slowly turn toward one another. When they finally meet, they do not collide. They begin to circle, bound into a single fragile atom that physicists call positronium. And this atom is unlike anything from the bright ages because it is wider than a galaxy. Wider than a galaxy, one lone atom. Its two particles orbit each other across a span that whole spiral arms of stars once filled, tracing a waltz so slow that a single turn takes ages beyond any name we have. For eons, the two of them spiral inward, closer by a whisper at a time, a courtship measured in spans that make the whole story of the stars look like one long breath. There is no hurry left anywhere. And at the end of that long, quiet dance, the electron and the positron finally touch and dissolve into a small flare of light. Two particles become two photons, a farewell glimmer in the dark, and then stillness again. This is what remains of all becoming. Physicists describe it with a word called entropy, which is simply a measure of how mixed and settled things are. In this era, entropy is nearly complete. The mixing is almost finished. Heat death, this state is called, though there is nothing violent in it. It only means that all the differences have evened out. No place is warmer than another place. No corner of the sky holds more than any other. And differences, it turns out, were what made everything happen. A star could shine because it was hotter than the space around it. A river could flow because one place stood higher than another. Change needs a slope to run down. Now the slopes are gone. Energy still exists, for energy is never destroyed, but it lies spread perfectly even, like a blanket smoothed across the whole of space. Nothing gathered, nothing steep, nothing left for time to work with. Time itself still passes as far as anyone can say, but time with nothing to change is a strange and gentle thing, like a clock ticking on in an empty house where every task is done and every door is closed. Some physicists wonder whether time even means anything here, since we only ever notice time by watching things change. Perhaps in this era, before and after quietly lose their meaning, the way a shoreline dissolves into a deep evening fog. If that sounds lonely, hold it another way. This is the universe at its maximum rest. Nothing is owed, nothing is unfinished. Every star that could shine has shone. Every world that could turn has turned, and all is complete. The stillness here is as deep as rest itself, deeper than any sleep you have ever fallen into, and it is not an ending forced upon the universe, but the place all its long unfolding was always flowing toward. Think of the last hour of a long good day. The dish is done, the lights out, the house breathing quietly around you. The dark era is that hour stretched wider than every age of stars and embers laid end to end. And even now the story may not be fully sealed. In a stillness this deep over spans of time we have no words for. The quiet itself may tremble. Quantum fluctuations, the physicists say, tiny flickers within the vast emptiness. No one knows what such flickers could do across a forever of chances. Some dreamers among the physicists suspect that, given time beyond time, the emptiness might stir and seed some small new beginning. It is only a maybe, a whisper. But maybes are their own kind of light, so let this long dark rest here, complete and calm, while the story turns to consider the other ways it might unfold and what those endings might mean. Sleep is near. And even that endless dark, that quiet ocean of almost nothing, may not be the whole story. The ending we have followed together is only the most likely one, the one the measurements point toward tonight. Cosmologists are honest about this. They hold their forecasts loosely, the way a sailor reads a weather map, knowing the sky can change. So before we come home, let us wander through the other endings, the other dreams. Everything depends on dark energy, that mysterious gentle pressure woven into space itself, the quiet force that pushes the galaxies apart. We do not know what it is. We only know so far that it seems calm and steady. But some physicists have wondered what would happen if that pressure were not steady. If dark energy slowly grew stronger over the ages, its push would deepen and the universe would come apart in a different way entirely. They call this idea the Big Rip. In that story, expansion itself becomes strong enough to unbind things. First, the great clusters of galaxies would loosen. Then galaxies themselves, their stars released like dandelion seeds into the widening dark. Near the very end of that story, even solar systems would open like unclasped hands, planets floating free, and at the final moment space would stretch faster than the smallest things could hold themselves together. It sounds dramatic, told quickly. But here is the quiet truth beneath it. Every careful measurement we have made of dark energy, from distant exploding stars to the faint glow left over from the beginning, says the same unchanging thing. It is not strengthening. As far as anyone can measure, the push stays constant, calm as a held breath. The Big Rip remains a tale physicists tell to test their equations, a storm forecast for a sky that keeps refusing to cloud over. There is another idea, stranger still, called vacuum decay. It begins with a question about the deep settings of reality, the hidden values that make atoms hold and light travel. Some physicists suspect those settings might not be final. If the universe rests in a valley that is not the deepest valley, Then somewhere, someday, a tiny bubble of truer physics could form, and it would bloom outward at the speed of light, rewriting everything it touched. And yet even this strangest of endings carries a tender mercy. Because the bubble travels as fast as light itself, no signal could ever outrun it. There would be no warning, no waiting, and no pain. Nothing would feel anything. One moment, the universe would simply become a different universe, the way a dream changes without the dreamer noticing. And the mathematics whispers that if it can happen at all, it is likely never or unimaginably far from now. So you can set that thought down like a stone beside the path. Our vacuum has held for nearly 14 billion years through every fire and every quieting, and it shows no sign at all of letting go. And then there are the gentler dreams. Some cosmologists imagine that the universe does not end at all, but breathes, that the long expansion might one day fold into a long return, gathering everything back toward warmth and beginning. In these cyclic pictures, our Big Bang was not the first morning, but simply the latest one, a bounce in an endless rhythm of universes, each rising out of the ashes of the one before, like tides, like seasons. No one can say if it is so. There is no measurement yet that can see past our own beginning, no telescope that looks through that first wall of light. The bounce stays a beautiful guess, a lullaby written in numbers. There is one more dream, and it may be the deepest of them all. Even in the emptiest void, quantum physics says that nothing is ever perfectly still. Space itself hums with tiny flickers, brief trembles of possibility. In any human span, those flickers amount to nothing, less than nothing, a shimmer beneath the floor of reality. But the dark era has no human span. It has forever, or something so close to forever that words give out. And given time beyond all counting, some cosmologists suspect the improbable stops being impossible. Overspans written as a one followed by more zeros than there are atoms in our galaxy. A fluctuation might rise that does not fade. It might be a small thing, a particle where none was, or it might, in the most dreamlike versions of the idea, be a seed, a fleck of order, dense enough to unfurl into a whole new universe. No one can truly say. It cannot be tested, only wondered about the way one wonders about the far side of sleep. But it means the endless dark may not be a grave at all. It may be a seedbed resting. A field lying fallow under a starless winter, holding within its silence the faint possibility of spring. Perhaps our own universe began this way, a flicker in some older dark, a dream that decided to stay, perhaps not. What matters here at the edge of everything we can imagine is how quiet all of these endings are. Every version of the far future arrives in peace. Each one unfolds over spans so vast that nothing living will ever feel them. And every one of them, rip or bubble or bounce or endless seedbed dark, lies unthinkably far from this warm room, this pillow, this breath, which brings us at last back to the one moment that is truly ours. And whatever ending the universe finally chooses, whether rip or hush or dreaming vacuum, it waits at a distance no mind can truly hold. So we turn around now and begin the long, quiet journey home. We fall back through the dark era, past the last evaporating black holes, past the ember worlds and the fading red dwarfs, the eons unwinding behind us like a road that grows brighter with every step. Trillions of years fold up like paper. The last star kindles again in reverse. Galaxies return to the sky, and the darkness we visited becomes a story once more, closed like a book on a bedside table. And here is tonight, waiting exactly where we left it. The same room, the same pillow, the same quiet air. Outside, the stars are still shining, every one of them alive, every one of them still young. Somewhere beyond the horizon, our sun is burning in the fullness of its youth, not even halfway through its life, with 5 billion steady years of light still ahead of it, pouring warmth across the small blue worlds. The universe itself is not yet 14 billion years old, an age that sounds ancient until it stands beside the trillions still to come, set against everything ahead. This is the first pale minute of dawn. We live in the era of starlight, the brief, bright morning of the cosmos, when galaxies still blaze with new suns, and the night sky is crowded with fires that have not yet learned how to go out. Everything we visited tonight, the last star, the Ember Age, the long goodbye of the black holes, all of it lies farther away in time than any word can carry. Between here and there stretch oceans of quiet years. If the whole life of the universe were a single long night, we are awake in its first few seconds, watching the earliest stars come out, long before even the idea of midnight has taken shape. The endings we imagined are real possibilities, and some of them are near certainties, yet they are so distant that no clock, no calendar, no language of numbers can bring them close. They cannot touch this night. Right now, starlight that left its home before there were people is arriving at this planet, falling on rooftops and oceans and sleeping faces, a quiet delivery that has been on its way for 1,000,000 years. Out of all the eras a mind could have opened its eyes in, ours is the one with skies full of stars, with warmth to spare, with mornings that arrive on time. That is a rare inheritance. Some far future being, if any exist in the Ember Age, might give anything to see what hangs above us tonight, a sky so generous with light that we hardly remember to look up at it. And yet the greatest treasures of this era are small ones, a warm blanket, breath moving in and out, the murmur of a house settling at night. These are things the far future will never hold again. Nothing in that distant story asks anything of us. The last star does not need our worry. The dark era keeps its own counsel. Tonight our only task is to rest inside the bright beginning of everything. And is that not a kind of gift, to be alive at the exact moment when the universe is most awake, to have a front row seat at the dawn, and a soft bed to watch it from? Tomorrow the sun will rise on schedule, as it has for 4.5 billion years, and it will go on rising long after every worry of this week has been forgotten. It is wonderfully reliable. The stars will keep their posts all night. The galaxy will turn its slow wheel, and the local group will hold together, gravity keeping the family close, the way it has since before the earth was born. So there is nowhere to rush to, and nothing left to do. The longest story ever told has been told, and it ends peacefully, and the ending is so far away that it is almost another word for never. You have traveled 100 trillion years and more tonight, out to the last flicker of the last black hole, and you have come home safe to a planet still warm under a sky still full. Let the eons go now. Let the far futures fold themselves away like maps after a journey. The room is close and quiet. The night is ordinary and kind. The universe is young, and so is this hour. Breathing slows all by itself when a tale reaches its end. The stars outside go on with their long shining, asking nothing, keeping watch the way they have kept watch over every sleeper who ever lived. Somewhere far ahead, the last star is waiting to be born, and further still waiting to go out, but that is for another age to witness. This age, this small bright hour of the universe, is for sleeping. So rest now, here at the beginning of everything, wrapped in the era of starlight, safe in the long bright morning of the cosmos. The stars are shining, the night is gentle. Good night and sleep well.